When UV light with a wavelength of 400 nanometers falls on a certain metal surface, the maximum kinetic energy of emitted photoelectrons is 1.1 eV. What is the maximum kinetic energy of photoelectrons when a wavelength of 350 falls on the same surface? This is the photoelectric effect. Kmax equals EE minus E0. So we are saying that the total energy of the electron is equal to the energy given to the electron by the photon minus the amount of energy that it took to get the electron off the metal. We're going to start by finding this E0, by finding the work function for a wavelength of 400. We're going to say Kmax equals hc over lambda minus E0. For lambda equals 400, Kmax is 1.1. It's going to equal 4.14 10 to the minus 15 electron volt seconds times 3 10 to the 8 over 400. You're going to want to plug all those in meters. Minus E0. Which then gives us so we get 1.1 EV is going to equal 3.105 minus E0, giving that the work function is going to be equal to 2 electron volts. That's going to be the work function for this metal. That value is not going to change in this second part. The second part, we have a wavelength of, I'll do it down here. Second part, we have a wavelength of lambda equals 350 nanometers. We're going to use the work function from up here. And so we want to find the kinetic energy when we're using that wavelength. We're going to use the work with this. Kmax equals EE minus E0. I'm going to use that work function. And we can find EE as well. That's going to equal hc over lambda minus work function. 4.14 times 10 to the minus 15 electron volt seconds times C over 350 minus 2.0. It's going to give us 3.5 EV minus 2.0. And we're going to get a Kmax of 1.5 electron volts. So the lesson to take from this is that the work function does not change. It's constant for a given metal. A solid barrier in the XY plane has a 15 micrometer diameter circular hole. An electron passing in the Z direction with a velocity of 0 in the X passes through the hole. What is the range of Vx after it passes through? What we're looking at is we have this plane here, the pink plane, that's in what we're calling the X and the Y. Coming up through the Z is an electron. that electron is going to pass through this circular opening anywhere but within a range of 15 micrometers. Because physics hates us, that means that we lose information about its velocity. We figured out some of its position, so now we can't know its velocity. The equation that we're going to use for this is the uncertainty principle. Delta x times delta p is greater than or equal to h over 4 pi. Delta p is momentum, so delta x times delta mv is greater than or equal to this. This is just a constant. This is just a number. Our delta x, delta doesn't so much mean change in this equation as it means the range. So our delta x is saying our range in our x position. Our x position can be anywhere within this small range, or anywhere within just this range. In this case, we don't know where the electron is passing through within 15 micrometers. That is the range in the x. That's our uncertainty. We don't know where within that 15 micrometers it's going to be. Our m, we have that. Delta v, that's what we're looking for. We're looking for our uncertainty and velocity equals blob of numbers. When you plug all this in, you wind up with a velocity uncertainty of plus or minus 3.9 meters per second. That's actually really kind of fascinating and horrible if you're trying to understand life or physics. Physics isn't real. So we went from knowing that it is exactly 0 in the x, then it passed through a small hole, which changed its wave, and now we don't know if it is going straight up in the x, or it could be going like that, or it could be going like that. We just don't know. Yeah. Physics sucks.